Where do the world's top data scientists and machine learning engineers think AI is really heading? How can you join them and break into your own data science, machine learning, or data analytics career? Those questions are what we're all about. My name's Jeremy, and welcome to the Mind the Machines podcast.
No matter what institution you're coming from, you can get access to the very latest research.
We also have to make sure that we're constantly revisiting our foundations and justifying why we're using the methods we are.
It's hard not to employ you. It doesn't matter what field you're in or what is it that you're good at. If you're good at something, if you like something with passion, there is someone who really needs you.
Aidan Gomez is a human logo soup of machine learning achievement. In addition to his undergrad at the University of Toronto and his current PhD work at Oxford, he's interned at Microsoft, worked with Geoff Hinton at Google Brain, and most recently he's founded FOR.ai, a distributed research AI organization that he'll tell us about, I'm sure, as we get into our conversation. But as if all that wasn't enough, he's also one of the authors of Attention is All You Need, the paper that sparked the most recent revolution in natural language models. Aidan, thanks for joining us.
Yeah, my pleasure. Thanks so much for having me.
So there's a lot for us to talk about here. So maybe we can start at the beginning. How did you get started in machine learning? What was your path like from machine learning novice all the way to Google and Oxford?
Yeah, so where I got started was kind of a chance encounter with an individual named Alejandro Isaza. And so in my second year, I was looking for internship opportunities for the summer. And I happened across this mobile development internship. And when I arrived at the company, I found out that what I was going to be working on was polyphonic transcription on device, on iOS devices. And so polyphonic transcription is when you listen to some audio source, music, and you write down the sheet music that corresponds to it. So we were doing this for piano music to make an app that tracks your location in sheet music so that you don't need to turn pages or these kind of annoying little features of playing. And the way that they were going to solve this was using LSTMs. And so that required that I learn a whole ton of machine learning that I had no exposure to in a very short period of time. And I got tons of exposure to writing GPU kernels for edge devices like iPads and iPhones. And it was basically through this that I really developed a passion and kind of got introduced to the whole field.
And what year was this?
So this would have been 2015. So I suppose only 4 years ago, but it feels like ages ago. So I was at this internship in Vancouver with Al, and kind of from there, what happened was I had kept hearing this name come up in reference to deep learning and neural nets, and Geoff Hinton was this big name, and I knew that he was at my home school, like where I had just come from. And so I reached out to Geoff, and he got back to me, and he put me in touch with one of the professors in the ML group at U of T, and that's how I got in touch with Roger Gross, which was the next person to kind of take me on and mentor me and kind of give me an academic side of neural networks. And from Roger, I got connected with Lukasz Kaiser in Google Brain, started working with him, working with Noam Shazir, Jakob, Ashish, all like this whole team, Nikki, who did Attention is All You Need, as well as One Model to Learn Them All. And after I returned from that internship in Mountain View, Geoff got in touch with me again, and he brought me to Google Toronto. And then from there, I'm starting my PhD here in Oxford as of this past October.
There's a lot of connection hopping, which is a really interesting feature of this whole journey. And something that I suspect is kind of undervalued generally. Like it seems like people often skip that aspect of career development, career advancement, where they fail to focus so much on doing what you just did. I mean, building these organic relationships and letting them take you where they lead.
Yeah, for sure. Yeah, there's a lot of connection hopping, and it's always trying to find common ground with the people that you want to work with or the people that you meet. And so when there's a spark, when there's a shared interest between two people, it just seeds this relationship that can turn into these major projects.
And what was that spark like with Geoff Hinton? Because I'd imagine with a lot of people, you could imagine they're focused on, say, if you're talking to an iOS developer, you get really into iOS talk. But with Geoff
Right.
Hinton, like how did you make that cold call? How did you build that connection?
So the first time I reached out to him, I guess the summer of 2015, he, yeah, like it was just very much an organic. It was basically the only name I knew in deep learning, and it was just, I knew his email, and I reached out and I told him about what I was working on, what I was interested in, some of the stuff that he did that I was interested in. I just asked, what do you think I should do next? What do you think about these ideas that I've had? And he, to my surprise, responded and gave me some feedback and pointed me in the right direction and gave me a next step to pursue.
What you're describing is a really good version of a reach out email. It's something that people undervalue and underdo, and just being able to be sincere about what you're doing, what your genuine common ground is, customizing it to the person rather than making it completely generic. And like that breaks through the barriers. Like I think we were talking about this earlier, but that breaks through the barriers of someone, even if they're super busy and they get 200 emails a day. If you get one email that says, hey, this is who I am, I have these thoughts, this is specifically why I think you would be the right person to tell me if I'm right or wrong about my thoughts, and I'd love to hear what you're working on. That cuts to the core of someone. Even someone who's as busy as Geoff even would have been back then.
Yeah, I totally agree. I think that whenever you're reaching out to I don't know, like someone that you want to collaborate with, or someone who's in a position that you hope to be in whatever time scale, half a century, 20 years, 10 years, next year, you always need to focus on not what you can get out of them, but what you can offer to them. And so it's about collaboration and give and take. Don't go into conversations or cold calls trying to get something out of someone. Just try to make a connection with someone. Try to kind of build a relationship first. That should be your priority. And so whenever I reach out to someone that I don't know, I don't reach out asking for things. I just reach out offering them things like topics that I'm interested in, opportunities for collaboration. I think that people are far more willing to help and willing to collaborate when they don't feel like they're being exploited. And so if you come to them with your ideas, like you're offering them something, they're going to be appreciative that you reached out.
That's the way to start a relationship off on the right foot. And even if what you're offering is, here are my ideas, like, what do you think of them? Here's something maybe as interesting for you to chew on. Mm-hmm. That's enough to kick someone off on the right foot rather than a solicitation.
Well, and I kind of want to say also, especially in the data science machine learning community, where there's sort of this open source ethos that translates not just into code, but also into people's openness to being contacted. I think I've seen a lot of that personally, where I'll reach out to someone on LinkedIn and I'll say, hey, I'm a fan of your work. I really like what you've done, and like I'll get a response, and oftentimes very quickly, where I don't feel like I in any way was entitled to one based on who I am and who that other person was.
It's amazing how easy it is to reach to the very top of this field. It's such a young field, and a lot of the founders are still around. And it's incredible how accessible they are. You can reach extremely high to very influential people, and they'll make time. And something about our field is that, there's been this intense focus on openness. And I think that's been around since the beginning. Like a lot of these journals that we publish in, like JMLR, the conferences like NeurIPS, ICML, ICLR, they're all open access for a reason. And we've had like staunch opposition to any these for-profit journals, or not for-profit, but these paid access journals trying to come into our space and trying to collect papers from our space. There's been really strong opposition, uniformly across the field at all levels.
And that's great. I mean, it's not like a lot of scientific disciplines try to do that, but can't bring together the cohesion. Like a lot, even in my field, physics, biophysics, and stuff. There's a lot of openness. Certainly, there's a lot of openness, but nothing like the universal degree that you see in machine learning. Like it's almost like it would be weird to see a machine learning engineer or machine learning publication that's paid.
Yeah, and one of the most shocking things for me is that even industrial labs are completely open. Like the publishing policies in these big industrial labs, you can't get machine learning talent without offering them the ability to publish everything that they work on.
Why do you think the field is open like this to begin with? What is it that accounts for this? I mean, you said it started basically at the beginning. Why do you think it started at that stage, and why do you think it's been sustained?
I think specifically within deep learning, the field was so fringe and it was so out of fashion and desperate for new contributors and people to just help, manpower or person power to kind of fuel this field, that it was open out of necessity. It was kind of born open to allow more people the opportunity to join and to kind of bring in more people. I think that's probably pretty fundamental to the culture that built out. And that's just carried through. I mean, a lot of those people who established that culture are still around, and they're still making pushes to keep things open. They're leading the academic and the industrial labs, and they've made it just a part of this culture to be open. You're an outlier if you're withholding valuable research.
And so how does this connect then to the work that you're currently doing? So you're currently at Oxford and I guess working as part of a Google collaboration, is that correct?
Yeah, so my current setup is I'm here at Oxford the vast majority of the time, and then I spend some time at Google, both in London and occasionally in Berlin. And so one of the amazing things about working with these industrial labs is that they are so open to collaboration. And they really do just want to push the forefront of research. And so the people that I collaborate with within Google Brain, they're often my collaborators when I do stuff in my academic lab as well. There's a fluidity, and it's really, it's beautiful.
Do you find, is there ever anything that is developed at Google that they keep hush-hush, or is the advantage more just Google scale? You can use 1,000 TPUs in production and no one can touch the performance of it because you have so much compute available.
Yeah, Google has placed a really strong emphasis on openness and collaboration. And of course, one of the primary benefits of getting to intern there or be a researcher there is access to incredible scale. But there's always a backbone of you're working to push forward the research, and you're working to publish and show the field what you've accomplished. And Brain has been pretty exceptional at achieving that, I think. It's definitely ingrained in this culture.
Speaking to your day-to-day then at Google Brain, and I guess at Oxford, it sounds like they're sort of, as you say, melded together. I mean, maybe there's less of a barrier between the two than one might otherwise imagine. But what does your day-to-day look like when you're working in these groups? Like, what sorts of problems are you working on today, and how are you working on them?
I'm super interested in multitask learning. That's kind of one of the topics that's fascinated me for, I guess, since close to the beginning. And so I'm trying to make a big push in that direction.
Sorry, do you mind explaining what multitask learning is?
So multitask learning, it's not multitasking in the sense of doing things simultaneously. It's one neural network with one parameter set being able to do multiple different things. So for instance, we often train an image classifier, but what if you could train an image classifier that also can caption the image it's given? So it's both solving the task of object recognition and classification and solving the task of describing the scene that's in front of it. And so often between these tasks, there's a lot of shared knowledge or similar solution strategies. And they can kind of feed off of one another, and there can be this transfer learning effect where the knowledge that you gain in one domain or in one task can be passed over to a new task. Yeah.
Interesting. So in this example, would you train your image classifier and then train a separate natural language model and try to put them together? Or
sure. So like you could imagine one extremely large network which It can take in an image, and then it shares, like it's one uniform network, and then at the very top, it splits into two paths. And one path leads towards a classifier, and the second path leads towards a language model or some language modality. And then you can train this thing jointly end to end, and the shared portion receives gradient signals from both these tasks. And so those shared parameters get information from both of these domains.
So basically, right at the junction of those two forks, like right at that place, is where the highest level concepts live that pertain to both, more or less.
Yeah. You want to pack as much of the processing into that shared portion as possible, so that you can facilitate the most transfer of knowledge between these two tasks. But yeah, there's a bunch of different strategies to come up with this. In one model, we took it to kind of the extreme, and we just had every modality we could think of: audio, video. I don't think we had video, audio, image, and text. And both on the input-output had these modalities which we could pipeline tasks through, and just had an enormous central body that just shared. It constituted 90% of the parameters of this model. But it received signal from all these tasks that we were considering.
So 90% of the processing was common to all of these different things that this model could do.
Yeah, exactly. Yeah.
It's sort of fascinating from almost a pedagogical standpoint, because when you make the analogy with the way humans learn things, people are constantly talking about understanding something by approaching it in many different ways. You have your kinesthetic learners, your visual learners, your auditory learners. All the senses kind of play into it, and obviously, even within a given sense, there are different ways of approaching a problem. It sounds like it's one of those, I guess, necessary moves to make if you're going to seriously try to take a pass at, say, some sort of AGI approach that's going to mimic the way humans actually interact with their environments.
For sure, yeah. I see it as a necessary component towards these kind of higher aspirations of artificial intelligence. That you need to be able to carry forward the knowledge of your past experience. When a human is given a brand new task, we are so data efficient as a product of our past experience. We're able to just bring all these tools and these solution techniques that we've distilled from however long our lifespan of experience, and put them towards a completely new task. Even if it's like rather different than what we've seen before, we're really remarkably adaptable and able to draw analogies and kind of pick and choose from the skills that we've developed from our past experience.
So your goal here is, in a sense, or an aspiration would be, you'd like to be able to train something like this maybe on a bunch of tasks, like 10 or 20 different tasks with this common parameter sharing, and then maybe be able to show that on the 21st task that it's never seen before, because it's learned these concepts from these parameters of all these other different tasks, it's able to very rapidly pick up this new task. And ideally, maybe show that for a lot of different tasks.
Yeah. And then really interesting questions start cropping up. Do we even need to show it demonstrations in new tasks? Can it solve tasks without demonstration? Like, can we just give it a new task and tell it, do this, without any examples, and it solves it? And so that's called zero-shot learning, and that's another really fascinating question.
And would that be considered zero-shot learning in the same sense as, you look at, say, the GPT-2 paper that came out from OpenAI, it seems to me that in this sense, you're talking about feeding it a bunch of labeled examples, or a bunch of examples that it uses, for want of a better term, different senses to probe. So it does have that information, but it just hasn't. It's zero-shot learning with respect to a particular sense among many. Would that be fair to say?
So in GPT-2, I haven't read the paper, just caveat what I'm about to say, but I believe what was done was an unsupervised pre-training on just simple language modeling, and then using that as an initialization, a starting point for their enormous transformer. they go ahead and carry on and fine tune on some downstream task, which may have limited data. So it's kind of like what you're saying with this. Okay, when you approach the n+1th task, is your objective to exploit the information that you've seen in the previous n? I think that what GPT-2 showed was that you can exploit that to an extreme degree. I think across the tasks they considered, they set new state-of-the-arts on nearly all of them. Although I'm not an expert on NLP, and I don't know what their baselines were like. But you can just see that like this pre-training just on one task with fairly limited data, I think it was like 40 gigs or something like that, is able to kind of just freshly rewrite a new set of sodas across a ton of tasks. And so this opportunity for transfer learning it's really massive.
Yeah, that's right. And I think what they did is they just did like a next word prediction, totally unsupervised. And then they ended up showing on a bunch of tasks, like answering questions about a text. I forget what the ambiguity score. I forget. Anyway, it doesn't matter. A bunch of like extra tasks that with zero shot they were able to do. I don't think necessarily all of them quite as well as the state of the art, but like all of them, like definitely your eyebrows go up when you see that it's a model that doesn't know how to do this task in theory, but all it knows is predict the next word, and it can still do this.
Oh, wow. Okay. Yeah. So they did some zero-shot evaluations as well then. Yeah. So the fine-tuning is more like a transfer learning question. But yeah, if you could just take a pre-trained language model and just stick it into some arbitrary other task.
Yeah, there was some disputed stuff about whether a few of the tasks were truly zero-shot, but it was either zero-shot or a small number of training examples.
Yeah, that's really cool. Yeah. Yeah, I mean, I think this kind of pre-training through multitasking, yeah, it's definitely one of the major benefits is going to be data efficiency and trimming down the number of labeled examples that you need to give these models in order to get a compelling intelligence back. Yeah, because with a lot of tasks, it's really difficult to get humans to demonstrate or to collect mass amounts of samples, the type of which you'd need to train a model from scratch. And so this might be, I'm not saying it's the solution, but it's definitely a strong step in the right direction.
I was going to say, it's the solution that we use ourselves. Like, we look at a small number of these examples from our peers, and we, like, from our experience as babies, like, doing stuff, bumping into things, and whatever we do, that's enough. Like, that plus whatever pre-training evolution has already provided us.
Mm-hmm.
Well, and what's also remarkable too is, I mean, we obviously have a long way to go to reach, human levels of learning ability, and yet we're not as far as it might seem. So, because I did a back of envelope calculation on the OpenAI data set, and they had something like 8 million Reddit posts, so probably hundreds of millions of words. And it turns out when you look at the number of words that babies typically exposed to before it learns how to speak, it's somewhere in the neighborhood of about 2 million. And so we're only about 2 orders of magnitude away, just based on GPT-2 alone.
Babies are exposed to do you say 2 billion or 2 million?
Sorry, 2 million, yeah, with an M.
Oh, 2 million. Okay, gotcha.
Yeah.
Oh, interesting. Wow.
So
that's a lot of words. I'm
is.
surprised that babies receive that. When do you start talking? Like two years old?
Yeah, around 2.
Isn't it less than? Oh no, it's less than 10,000 words a day. That's still a lot of words. It's like some single-digit number of thousands of words per day. That sounds like a lot of words. Still, if you have to give them 2 million words before you strap them into,
yeah, you really got to fill them up. Yeah. Focus your time on just babbling to.
Just read the dictionary. That's
yeah.
So for all the parents out there, make sure you give your baby 2 million words worth of exposure.
Part of a complete breakfast, yeah. So the other thing I wanted to get to as well is you are doing this interesting work at FOR.ai, or I think just FOR is like the general name of the company?
Yeah, so with FOR, the idea behind it is to give anyone from any background access to fantastic mentors in machine learning and neural networks, as well as access to resources like TPUs, GPUs, like the whole compute resource aspect, which is tough to get your hands on if you're not inside a large institution. So it started when I was returning from my first internship at Brain. I came back to U of T. I had a bunch of ideas for projects that I wanted to take on, but I didn't have enough hands. And so I just sent a message to U of T's computer science chat that we had among students. And I said, hey, if anybody wants to work on some projects with me, I'd love to collaborate. So I put together a team of 5 people, and we just named ourselves FOR.ai. And we started on our first project, which was CipherGAN. And so it was Ivan, Brian, Sheldon, and Osama. And the 5 of us just went at it, and I think we've created a really cool group since then. We've grown. I think we crossed something like all but 2 of the continents, and we're all over the world now. And since our U of T days, we've taken on people from big academic labs and industrial labs as well. And then we take on mentors from all over the place, like Google Brain, Toronto, Vector Institute, Oxford. And so we give people a lot of access to, top tier resources.
And so your goal is basically to be an open, you guys produce research and publications.
Yeah, that's totally the objective, is to kind of, well, for one, it's to give people the opportunity to learn, but for most of us, the goal is to do new stuff. It's to create, new research and to publish and explore ideas that we find interesting. And so we kind of congeal around these core projects within the group on some topic area, like RL, or previously we were interested in GANs and then adversarial examples. And so we kind of congeal into groups around these, and we just all collaborate every single day. We're always chatting on Slack and working away together. Yeah, it's turned into like a really nice community of really brilliant people. Yeah.
One of the things that I'm constantly struck by is how low the intellectual barrier to entry is to this field. So
Yeah.
People are constantly assuming that you need to have a PhD or you need to have a master's to be able to contribute. But
Right.
I think ultimately, and something that you guys really definitely bring to the table is the idea that you just need really good mentors. You just need good guidance, and most people can get themselves from 4th year undergraduate calculus and linear algebra, and then use that to propel themselves into this field. But they just need to know what to learn.
Yeah, I guess like we were saying, like one of the fantastic parts of this field is the openness and the dedication that has been put towards making it easier for newcomers to pick up and just get started on projects right away. So things like Coursera, they really enable people to get their feet into the field. And then as soon as they have the kind of technical backbone to be able to maneuver, you can just give them a project, give them an idea, and they'll be able to run with it. Yeah, so I think it's super valuable, this openness. Like it's really opened it up to everyone across the world, no matter what institution you're coming from. You can get access to the very latest research, the kind of the state of the art, open. Yeah, and so the one thing that perhaps needs to be made easier is access to mentors. And so hopefully FOR.ai can contribute in that way. We can give you people who are a little bit more senior than yourself to guide you or point you towards new topics, or unblock you and kind of give you ideas to seed whatever your next project is.
That is one of the most important things. One of the things we've seen that's the hardest for someone starting out is knowing just what kinds of problems are right to tackle. It's so easy to undershoot the difficulty or to overshoot the difficulty. Like the edge of the field is a very very narrow kind of thing, and it's easy to be like, here's a project. Oh, that's way too easy. We've done that. That's solved like 2 years ago. Or here's a project, and no, that's utterly impossible.
One of the most valuable part about working with much more senior mentors is that they really know where that boundary is. Like they're the ones pushing that boundary forward. And so it's less like the technical, like, hey, this is how you debug this, or like, let me unblock you in this piece of code. It's more of the guiding. This is a problem worth working on. This is, something that people aren't thinking about, or that hasn't been done before. Identifying those is what experience gives you the ability to do, and so that's why these more experienced mentors really do add value to the younger ones.
I'm so glad you guys are doing that. It's exactly what the field needs. Definitely a big focus for us too, as well as we've been talking about on previous podcasts. Now, one thing I'd want to do is make a little bit of time too to talk about the future of AI, because this is something that you're kind of steeped in implicitly. You're quite literally building the future of AI. What are the big directions you see coming? Is reinforcement learning, which I think it's fair to say most people see that as like the gateway potentially to full-on AGI in concert, obviously, with other things. What's your sense? Like, are we ever going to get to that AGI? What might it look like? What definition might you apply? I mean, I have so many questions, but maybe you can just pick up the ball there with any thoughts that you have off the top.
I won't be so arrogant as to say that I know the timeline, and I think
Probably a good move.
Smarter, yeah, a lot smarter people have made estimates and been horribly wrong. So I think it's anywhere between 5 years and 5 millennia. So it's coming. I'm not sure when, but I think that for sure RL is going to be an enormous component, and it can take us part of the way. I'm not a subscriber to the belief that scaling compute is going to be the solution to all our problems, which Rich Sutton would disagree with me on, perhaps. But I think that for sure, like all these components, we're kind of building these fundamental pieces and slowly patching them together. I think earlier on, our domains were kind of siloed. We had vision people, language people, and then nowadays, we all kind of just work on neural nets, and they do language and vision, and they're kind of this cohesive technique that can be applied across a bunch of domains. And now we have RL, which is escaping from the supervised regime, or at least in some sense escaping from the supervised regime. And so that's another really promising avenue. I don't think we're going to leave behind, all the stuff that we've worked on so far, but we'll pick it up and we'll take it with us. And so the next problems, I think something that really interests me is modeling our world and model-based RL, especially for efficiency. I don't think we're going to get to whatever we want to define AGI as exclusively by writing better simulators and having everything trained in sim and then trying to transfer to the real world. I think modeling the world using machine learning is kind of the most promising way to train within these modeled environments. So that's something like world models is really exciting to me, and it's something that we're looking into in FOR.ai at the moment as well. I think that's a really exciting next step.
One thing that you did hint at, and I remember you mentioning this in a previous conversation that we'd had, was just the importance of sending some of these agents out into something like the real world. We talked about embodiment and this idea that some people think that the only way to reach true AGI is to, one extreme says you actually have to make something that looks like a human and that walks like a human, talks like a human, before it'll actually pick up all the things that humans know. And sort of the extreme example of that case being Sanctuary AI, where they're making these what they call synths that run around Vancouver and interact with people. But then you brought up an interesting kind of middle ground that I thought was worth flagging here, where you were talking about maybe we don't need to go that far with the synths, but we certainly do need some form of let's say less than human embodiment, some device that can interact with the real world. Do you mind elaborating on that idea?
Yeah, so what we spoke about last time, I think the idea of embodiment maybe doesn't fall as short as, like you say, like a humanoid robot running around. And sure, that sounds great. And I think that if we had robotics like that would be fantastic, but we're definitely not there yet. I kind of view embodiment as just saying a modality to the real world, the universe. And I don't necessarily, for sure, robotics is one really compelling way of getting access to that. But I also view access to the real world as engaging in social media, these places where humans inhabit these environments and they are part of, whatever you want to call the new natural world. Even though they're digital, they're these complex live environments which our agents can interact with. And there's definitely some difficult moral questions when we send out agents into human spaces and try to get them to interact with us. But I think that's where the most compelling, those are the most compelling environments, right? Like those are the end goal environments for us with the intelligent technology we're trying to build. We want to deploy them in these environments. And so coming up with modalities for them to interact in those environments is, yeah, it's a challenging problem. I mean, robotics is getting there, but yeah, I mean, there's definitely, it's hard to say things like those humanoid, hyper-realistic robots. I don't know if we need to go that far. I think we can have really compelling robotics without the anthropomorphic aspect.
So your core philosophy here being that, I guess, you don't want to run the risk of having an agent overfit to some artificial environment like an OpenAI gym, no matter how elaborate it becomes. Because ultimately, I mean, to some degree, that relies on a human doing what effectively becomes a sort of feature extraction, where you decide, oh, here are the relevant aspects of the real world. Yeah. I'm going to condense them down, and I may or may not be actually hitting the nail on the head here. Maybe some of the
it's removing the human bottleneck in constructing these environments and being smart enough to include all the relevant components, right? Yeah, there is a human feature extractor when you're building really good simulators. They're no replacement. They'll never simulate sufficient complexity.
And we are not as good at doing that as we would like to think. Even really good ones, not just in terms of extracting features, but in terms of making an environment that is hack proof. Like, especially when you have an RL agent, like there are story after story of agents that just hack the rewards function that we put into them. And
there's some work from OpenAI on, I think, unsupervised reinforcement learning from I believe his name is Harry. And what happened was the Mario agent learned to break the simulator and just reach this point where the screen just started flashing and it was hyper-entropic and it received tons of reward for doing that. And so it would always just try and break the simulator. It's fascinating. It's a great, I guess, stress testing technique for these simulators.
Yeah, it's almost like a new kind of chaos monkey strategy where you just drop in this RL agent that's geared towards exploration and just watch the world burn.
You watch the world burn, yeah, exactly.
So this is a really interesting conversation, your perspective on whether or not machine learning, or rather, I should say AGI, is going to come to be. And I guess the definition of AGI obviously is something that's very fuzzy, that no one's quite pinned down. But I assume we'll know it when we see a machine making a gigantic number of paperclips someday. But in terms of, actually that kind of pivots us to the next thing I wanted to ask about, which is the risk. What risks, what ethical problems do you see personally being at the forefront of this AGI discussion? I think everybody has their pet concern, and I think it's fair to say most things are concerning to most people. But if you had to pick one or two that you're especially kind of keeping your eyes on in the short, medium term, what would those be?
Yeah, so for me, there's the long-term AGI concerns, and there's lots of theoretical moral issues and ethics problems that are fascinating. But what kind of occupies my mind most at the moment is it's relevant today, and it's a risk today, and that's machine learning models that are being deployed on digital platforms to serve content. And kind of the checks and balances that need to be in place for organizations that want to bring these to market and actually interact with humans. Because we know that the media we're exposed to has profound impacts on our well-being, our beliefs, our contentment. And basically, we have these algorithms which are trained to maximize some arbitrary metric, like time spent on sites, clicks, revenue derived. It's, the effect on the downstream user, the one that it's trying to influence, I don't think it's looked at closely enough. So I think that we need greater checks and balances on these systems before they're deployed, and we need people really thinking about how do we evaluate these systems, or we make sure that our evaluations can't be kind of skirted around. I really think that, you know, in social media, the posts that you're presented with, the sort of posts that you're given, they can silo you into belief systems, or they can impact your mood or your worldview. And so this is a really personal and vulnerable part of humanity and our psyches that needs to be kind of protected, and we need to be given the autonomy to kind of, you know, not get siloed, or to overcome these algorithmic, what do you want to call it, these algorithmic worlds that are constructed around us, for objectives like maximizing time spent on site, that type of thing.
I find it really interesting that like your framing is a really interesting one, because it sort of rests atop a more fundamental discussion about what freedom means to a human being. When left to our own devices, we construct a Twitter feed that reflects back what we already believe and entrenches those views more and more. I think that's generally fair to say, though we have, you know, there are a select few people out there who are better than me who actually make sure that their Twitter feed does not do that. But that seems to be a trend. And so when you kind of like, when you give a human the ability to like pump themselves full of let's say political drugs in that sense, they're going to keep hitting that big red button over and over.
Right, even if their better senses know that they shouldn't. And so if you give them the autonomy to override that kind of automated behavior, you know, what happens? Those are super interesting questions. And I think that there's a really big space for someone to come in and to kind of enable people to make those decisions, give people the autonomy to make decisions about the type of content they see at a higher level, construct a kind of meta objective that they want to, maybe it's, I want to increase my happiness. And then what this product does is it becomes its own, it replaces the ranking algorithm on social media X, and it pushes you towards your goals. I think that's a really fascinating product. And I think that it actually increases user autonomy.
Yeah. And there's also, I guess, the question when you talk about happiness, and this is the age-old question of what is good, what is happiness, but and I don't want to dwell on it too much, but I do think there's something interesting to the question of like, on what time scale are we talking here? Because there's, you know, what will make me happy 2 seconds from now is, you know, if I'm a Democrat, I want to see an article that trashes Trump. If I'm a Republican, I want to see an article that backs Trump. I'm going to be really happy. I'll get that dopamine hit. But on the flip side, like 3 years from now, I'm not going to be particularly well informed about the state of the world, and I'm more likely to be working on irrelevant things, lose my job, have fewer friends, and so on and so forth. I guess I wonder, like, to me, and I'm not sure, you know, how accurate this is. I always have this instinct that it's like a battle between the cortex and the limbic system, where our limbic system just is driving us to keep curating that Twitter feed. And the cortex wants to look further down the road. And because there are almost two versions of you at that point, there's the version of you that just wants the thing now, and then there's another version of you that says, hold on, like, let's apply some more abstract values to this approach and try to map things out more carefully. There's almost a bit of an open debate about which version of you is right and which one actually ought to be satisfied or given that sort of control. I wonder if that sort of complicates some of these issues, but
no, I think it definitely does complicate those issues, but I think that's something that, you know, whatever this system that I'm imagining, I think this is something you need to make a decision on what your personal take on that issue is, and be able to express it to the system, and it will abide by it. And so if your take is, you know what, I don't want that immediate reward, what I really want to optimize for is down the road, I want to be the most informed I can be, then it's going to give you a diverse set of opinions, and maybe that's something you value. Or you want to say, I don't want to risk falling into the traps of media source X. I don't want opinions from this side. Maybe you do want to kind of just silo yourself down into one particular avenue. You should have the ability to choose, right? Like, we should have the ability to choose.
So in essence, you yourself become the arbiter of who has to win between the cortex and limbic system, and then
Yeah.
I really
It
like
might
that.
change one day. Yeah.
And so, are these conversations happening within, say, Google and Oxford or whatever communities you tend to work with, or is this sort of more of I don't know, is this water cooler talk there? Is it talk at all, and is it executive talk?
Yeah, so for sure, like every single group that I'm a part of, these moral issues are really in the forefront of our minds. I know within Oxford, we every week have a discussion group, and it's always on topics like this. And all of us are thinking about this and debating each other. A really fantastic feature of the machine learning community is that it's right out there in the open. There's been like a consistent and just a consistent voice echoing that these concerns need to be considered by everyone from the lowest level, feature engineer to the like highest level philosophers. Everyone needs to be thinking about this all the way down. And there's been a really great open discussion about these topics. And I don't think there's rarely ever consensus, but there is discussion, and there's the opportunity for people to form their opinions based on really well thought out arguments which people are presenting. And so I love this kind of like blog format where people really thoroughly think through an idea, and I get to kind of explore through their eyes, their take, and I get to do the same on another side of the issue. Our field's been really good at communicating different arguments for these moral questions that arise.
If there's any field that's got to be good at that, it is this field. So I'm very glad that it is. Yeah. Well, then to wrap up, maybe one last quick question for anybody who's interested in mimicking your rather admittedly unique career trajectory. What advice would you have to somebody in that position?
I think the core guiding principle is take appropriate risk. And so to begin with, I think the strategy or the policy you want to take is don't be afraid to take risks. Just insert yourself into the community, take on projects that are ambitious, that may be out of your comfort zone, to expose yourself to opportunity. Especially early on in your career, I think that a lot of the time we want some safe trajectory towards learning or towards following what we're supposed to do, like this traditional education path. But the people who really stand out are the ones who stray from that. And so don't be afraid of risk, seek it out. And I think that oftentimes it'll pay off, often enough.
Awesome. Well, thanks so much. I'm sure that insight's going to be really useful because it is an area where I think a lot of people do struggle is deciding to take that leap in whatever form it might take. So thanks a lot for making the time for this chat. I learned a ton. I always enjoy these, so really appreciate you stopping by.